Hi, welcome to Mathematics of Chemistry Part 7. My name is Dr. English, and today we're going to be talking about dimensional analysis and how to do one-unit conversions. So the first thing that we're going to do is a little review of dimensional analysis and conversion factors. Think about where does the problem start, using conversion factors, figuring out where does the problem end, asking ourselves the important question of does the answer make sense, talk about some one-step conversion examples, and then finally wrap it up with some multiple-step conversion examples. So to get started, let's do a little review of dimensional analysis and conversion factors. So what is dimensional analysis? Dimensional analysis is a mathematical method that converts a given quantity and unit of measurement into a different unit of measurement. So we're converting from one unit to another. In order to do that, we need something known as a conversion factor. This is a numerical ratio that uses two equivalent quantities labeled with different units. Conversion factors can be inverted because the conversion factors are equal to 1. So our first question is, where does the problem start? So let's look at an example here. Convert 0.541 kilograms into grams. Our first step is to identify the known quantity, the number that they give you, and the accompanying unit from the original word problem. So in this case, the known quantity would be the 0.541 kilograms. And then the next thing that I teach my students to do when we're doing dimensional analysis is to draw a multiplication sign and a line after writing the known quantity. The next thing that we need to figure out is what conversion factor to use. So let's look at our example again. Convert 0.541 kilograms into grams. So we need a conversion factor that's going to work for us here. So step 3 is identify the correct conversion factor to be used. Most likely, Table C can give you some help on how to approach this. So I see kilo right here, and kilo means 1,000 of something, 10 to the third, 1,000 of something. So one conversion factor that I could use is 1 kilogram over 1,000 grams, with grams being my base unit, or I could use 1,000 grams over 1 kilogram. So up to this point, what we have here is our given, which is right here, our given, along with the correct unit, and then I want to make sure that I set this up, and we'll go over this again in the next slide, with whatever unit I'm starting with, that's going to go on the bottom of the conversion unit, and whatever unit I want to end with goes on the top of the conversion unit. So the appropriate conversion unit to use here is this one, because I want to be basically nullifying the kilograms and ending up with the unit of grams. So when you look at these conversion factors, remember they could always be converted because the factors are equal to 1. So where does the problem end? The problem is going to end when you basically get to the unit that you want. So let's look at our example. Convert 0.541 kilograms into grams. Where I'm ending here is when I get to the unit of grams in my setup. So make sure you can cancel the appropriate units down and to the right. Finally, we want to complete the calculation using the proper math and the final unit. So here again, I have my given. This is my given here for my original problem, and I have it labeled. That's half the battle, is labeling. I have my multiplication sign right here, and then a line drawn. Whatever unit I start with, in this case kilograms, that unit is going to go on the bottom. I want to end with grams, so that's going to go up on top. I know I have this set up correctly because kilograms can cancel kilograms, so that particular unit is gone. So when I do my multiplication through 0.541 times 1,000, I'm going to get my final answer of 541 grams. And again, grams is where I want to end up. Therefore, I know the problem is complete. You really need to ask yourself the following questions as you go through doing dimensional analysis problems. Have you written out the correct number and units to start with? If you don't have the correct number and the correct units to start with, your problem is not going to work out. Did you draw a multiplication sign and a line after writing that known quantity that was given to you? Did you identify the correct conversion factor to be used? Did you make sure that you can cancel the appropriate units down and to the right. So you always want to make sure that whatever unit you're starting with, that's going to be on the bottom of your conversion factor. Whatever unit you want to end with goes on the top of your conversion factor. So you can cancel those units down and to the right. And taking that little step to do that is so incredibly important to making sure that you'll get the final answer. And the last, did you complete the calculation using the proper math? Do the proper math and make sure you label it with the final unit. Does it make sense? You have to ask yourself that question. Let's look at some one-step conversion example. Convert 2.00 meters into centimeters. Let's start this up by making sure that we have the correct conversion factors. I need a meters to centimeters conversion factor. I know that 1 meter is going to equal 100 centimeters, so I'd have that ready ahead of time. The first thing that I'm going to do is write down my given. 2.00 meters, then I'm going to write a multiplication sign and a line. If I'm starting with meters, meters is going to go on the bottom and centimeters is going to go on the top. And then I look over my conversion unit right over here. I know that there is 100 centimeters in 1 meter. And then again, can I cancel down and to the right? Meters cancels meters. So therefore, my final answer when I work the math out correctly is going to be 200 centimeters. So I'm ending up with the unit that I want and my math makes sense. Let's look at our next example. Convert 15.6 inches into feet. In order to do this, again, we need a conversion factor. In this case, 12 inches is equal to 1 foot. So the first thing that we're going to do here is write down our given. 15.6 inches, multiplication sign, and a line. Whatever unit I start with is going to be on the bottom, so that's inches, and whatever unit I want to end up with is going to be on the top. So in this case, that will be feet. I know that in 1 foot, there's going to be 12 inches, so I'm going to put a 12 on the bottom, and then I'm going to put my equal sign, and then again, I need to make sure that I can cancel my units down and to the right. Inches cancel inches, so 15.6 times 1 divided by 12 is going to give me 1.3 feet. Again, I know that I have this set up correctly because my units cancel out, my math makes sense, and I've labeled all of my units and I'm with the final unit that I want in feet at the end. Now let's talk about multiple step conversion examples. So instead of just being one step to get from the start to the end, now we're going to look at a couple that have multiple steps associated with them. Same type of process though here. Convert 1.50 millimeters into kilometers. To do this, we need a conversion factor. So I know that there's 1,000 millimeters in 1 meter and 1,000 meters in 1 kilometer. So again, I'm going to start out by writing out my given. 1.50 millimeters, multiplication sign, and a line. Now, I know that there's different ways of approaching this. You could do it in just one step if you wanted to. When I approach these problems, I like to go towards a base unit and then away from a base unit because that's where I feel most comfortable. So 1.50 millimeters. Millimeters is going to go on the bottom. I have a conversion factor here to get me from millimeters to meters. So I'm going to put meters up on the top. And then I'm going to backfill and I'm going to say 1 meter is equal to 1,000 millimeters. And then I can look at this and say, well, millimeters cancels millimeters. Those units are canceled out. I'm left with meters. But that's not where I want to end up. I want to end up in kilometers. So I'm in a base unit right now, and I can use this other conversion factor to get there. So I'm going to put a multiplication sign and a line, and I know that there are 1,000 meters in 1 kilometer. Again, I want to make sure that my units cancel down and to the right. So meters cancel meters, and I'm left with kilometers, which is the unit that I want at the end. So when I multiply this out, it's going to be 1.5 times 1 divided by, and then if you put this into your graphing calculator, you want to put it in parentheses, 1,000 times 1,000, end parentheses, hit the equal sign, and you should get 1.5 times 10 to the negative 6 kilometers in scientific notation, or it could be 0.5 1, 2, 3, 4, 5, 1, 5 kilometers. So 5 zeros, 1, 5 kilometers. Either scientific notation or standard notation. It really depends on how your teacher wants you to approach your final answers. Let's look at another example. Convert 5 inches into meters. Again, we're going to need some conversion factors here. I know that 1 inch is equal to 2.54 centimeters and that there's 100 centimeters in 1 meter. So like I've said before, the first thing that we're always going to do is start out by writing down our given. 5.00 inches, multiplication sign and a line. If I start with inches, inches is going to go on the bottom. And I have a conversion factor here to go from inches to centimeters. So I'm going to get this into centimeters. So 2.54 centimeters is in 1 inch. And I converted to centimeters here because ultimately I want to get to meters, and I know that there is a conversion factor readily available that will take me from centimeters to meters, specifically this one right here. So I'm going to do another multiplication sign and a line. If I have my inches units cancel out, I'm left with centimeters. So if centimeters is on the top, then I'm going to put centimeters down here so I can cancel down and to the right. 100 centimeters, 1 meter, so meters will go up on top, which is ultimately where I want to end up. So I know that in 1 meter, there's 100 centimeters. And again, I can cancel my units down and to the right, so centimeters cancels centimeters. And if I do 5.00 times 2.54 times 1 divided by 100, I will end up with 0.127 meters as my final answer. So what did we learn in this tutorial? We did a little review of the definitions of dimensional analysis and conversion factors. We talked about how to set up a dimensional analysis problem. We talked about how to use a conversion factor, how to realize when your problem is done, asking yourself, does the problem make sense, looking at some examples of one-step conversions, and then finally looking at some samples of multiple step conversions. Need more help? Feel free to contact me. Have a great day.